Go Language Programming, Chapter 2, Unit 7. In this unit, we will be looking at the new operator. So the new actually not an operator. It is a new function that allocates the memory dynamically, and that way you can allocate as much memory at runtime from the heap. Okay, so creating a pointer variable using the built-in new function. So the new function is provided by the Go compiler. So the new function takes a type as an argument. So this, within this parentheses, you put a type, either int or char or whatever the type of the memory that you want to allocate. So that is the arguments that it takes. It allocates enough memory to accommodate a value of the type. Okay, so it will allocate basically a memory for that type. So if it's you're using a CHR, that means a 1 byte. So it will allocate enough memory for 1 byte. The new function returns a pointer to the allocated memory. So once it allocates the memory, okay, then basically what happens is it will give you the starting address of the memory where the memory was allocated. So so you can save that address into a pointer variable. Okay, so that's how the new operator will return. So new operator will always return a address, so that, as we have talked in the previous slides, that the addresses can only be saved into a pointer variable. So that means that you must have a pointer variable, and we will see the syntax in a minute. When new function is used, compiler will always allocate memory from the heap. Okay, so heap is a part of the memory. There are two different part to store the data. One is on the stack memory, and the other one is a heap. So when you use a new operator, it always will allocate the memory from the heap. And the stack memory, when you create some variables, that stack memory will be either sometimes when you create a variable in Go language, sometimes it will be created on the stack, and sometimes it may create it or allocate it from the heap. It really depends upon the compiler. That's what the Go language spec says. So the regular variable that we have been declaring with colon equals to or with the var, those variables can either be on the stack, or those variables can either be on the heap. Okay, so but if you are using a new operator or the new function in Go language, it will always allocate the memory from the heap. So if new function is not used, memory allocation, compiler may decide to allocate memory from heap or from stack. Okay, so that really depends upon on the compiler, even for the regular variables. So to see where memory is allocated, use this switch when you are compiling your code. So -m switch will tell you where the memory is allocated from. Is it from the heap or from the stack? Okay, it will tell you. So I'm pretty sure when you write a code, you have to allocate the memory. Without allocating the memory, your program is no good. So either you allocate the memory from the stack or from the heap. So in this example, which is 2-25, we will see how the memory is allocated using a new operator. Okay, so to do that, since we want to be able to execute this program, we are using a package main, and then we are importing the FMT package, so we can use print line function from this FMT package, and then we have to have a entry point function main to start our program. Without the entry point function, your program would not run. So we declared a body for it. So first we use a func keyword to declare the main function, and then we create a body with left braces, which is on the same line as the function name, and then the right braces, which will tell the compiler that is the end of the function. And then at line number 5, we are creating or allocating the memory of type int, okay, from the heap. And as we just talked about, that when you do that, it will basically give us the address of that where the memory was allocated, and that address must be saved into this variable. So since it's going to be returning this function main, a new function will be returning an address, the compiler will automatically create this ptr1 as a pointer type, okay, pointed to an integer. So that's a compiler's job to do. And then once that memory is allocated, what we can do is we can store some data, okay, at that memory. So to store that data, we have to do the dereferencing on the pointer and store the data. So if I draw the diagram right here, it may help you to understand what exactly is happening. So so the new operator will allocate some memory at some address, let's say at 4000. Okay, it allocated the memory when you did this, and this memory is of type int. So as soon as you allocate it, it will have compiler will automatically will initialize this to nil. Okay, so it will put nil in here, and then it will pick up this address and create. So we are creating at line number 5, we are creating a pointer type variable. Okay, so this is ptr1, and of course this ptr1 will be created as some address location as well. We just say 7,000, and when the new operator is used, when it returns it, we are using a short declaration with the colon equals to. That means copy this 4,000 address to right here. Okay, so that means this is pointing to this memory now, after this line number 5. Okay, now at line number 8, what we are saying that we want to dereference. So we are saying that, okay, go to this address ptr and dereference. So dereferencing meaning go and get the data which is I mean, not get the data, but initialize the memory where this pointer is pointing to. So we are initializing this memory to 10, and so no longer it won't be a nil. It will have the 10 in there. And actually, initially I kind of made a mistake by telling that this memory will be a nil. It really would not be a nil because we created a type, a integer type memory, so it actually will be a 0. Okay, 0 is not the same as nil. Nil will only be initialized for the addresses. But in this case, this piece of memory holds the values, okay, because we are asking it that create memory that will hold the integer type values. Okay, that's what we are doing right here. So when we do this part right here, ptr2, now ptr2, when we created line number 10, okay, ptr2, and when we create that one, it will be created at some address location. Let's say it is created at x 3000, okay, and it will be a pointer type. Okay, so in this case, this will be a zero value, so this will be a nil now. Okay, this will be initialized to nil. And then in line number 13, we are using a print line function to print what each um, uh, each pointer holds. Okay, so when we do this, the ptr1 holds the address of this memory right here. So in our case, since it's a compiled code, so it gave me this address, but according to the picture, it actually will print out this 0x4000. Okay, and this one that we created, it will have a nil, so it will print the nil right here. And then at line number 15, we are saying that, okay, make the ptr2 or get the same address or assign the same address to ptr2 as the ptr1 is holding. So that's what it is going to do. It is going to copy this this address, which is 4000, to here. So this would not be a nil anymore, it will be a 4000 right here. Okay, because of this initialization. And when we do the print at line number 18, this and this address will be same right here. Okay, and now we can use the ptr1 and show that the address of the ptr1 that it is holding, and we can do the dereferencing of ptr1 and get the data. Okay, so in this case, ptr1 is pointing to a 10, so it will print out the 10. Okay, so that basically is the last example in chapter 2, unit 7, and that concludes this this chapter.